Hello, I'm Chris McCarthy from the American Chemical Society, and welcome to this news briefing from the ACS Fall 2020 Virtual Meeting and Expo. We're joined today by Dr. Teresa Longin and Dr. David Soulsby from the University of Redlands. They're studying how sour beer gets so sour. Dr. Longin.
Well, thank you all for the opportunity to talk to you about our research. Our work focuses on studying what compounds are present in barrel-aged sour beer and how the concentrations of those compounds change over time. To start with, we thought we'd tell you a little bit about the process of making sour beer. Like all beer, sour beer starts when the brewer boils grains like wheat and barley to release the sugars. And then the brewer adds a mixture of yeast and bacteria, or can just leave the beer open to the environment so that feral yeast and bacteria fall into the beer and allow it to ferment. And so the yeast and bacteria begin converting the sugars into a whole plethora of interesting compounds. And then the brewer takes that beer and puts it into barrels for often up to 3 years. The final barrel-aged beer is often sour or tart with other flavors that include things like floral, fruity, or even funky. And these different flavors come from the complex processes that are occurring during aging. And these processes are hard to control and can be hard to reproduce. So our research really focuses on understanding what these processes are, what's happening over time, so that the brewer can ultimately understand them and make better beer.
Excellent. Let me talk a little bit about our research right now. So in early 2019, we contacted Brian Doty, who is the head brewer at Sour Cellars, to see if he would be interested in working with us on this project. Brian is a passionate and knowledgeable brewer who was very interested in understanding how his beer ages so they can ultimately make better beer, which is our project. He agreed to work with us and started collecting samples from different batches of his barrel-aged beer, some of which you can see in the picture, every 2 to 4 weeks over the course of about a year. With the samples in hand, we then used 2 different instruments to analyze these samples looking for different compounds. So we used nuclear magnetic resonance spectroscopy, or NMR, and liquid chromatography time of flight mass spectrometry, or LC-MS. Using NMR spectroscopy, we tracked the major compounds that are present in sour beer, and these included ethanol, lactic acid, acetic acid, and succinic acid. These all give that beer that kind of sour, puckerish flavor. And these are all generated from the interaction of the yeast and the bacteria in the beer. We then tracked how each of these compounds change over time and over each batch of beer. And even though, surprisingly, all of Brian's beers, sour beers, start from about similar recipes, we found that the rate of development of these compounds were actually quite varied over time and over batch. The bacteria that are responsible for these acids can take a while to establish themselves, which is what we believe is behind these results, but the barrels themselves also appear to be important contributors to this variation.
For the LC-MS work, we've identified a number of compounds, and most of them are nitrogen-rich compounds. For example, we found hortitines, which are compounds known to come from barley, and they have antifungal properties. We found the amino acid tryptophan, and we found a compound that is the product of the reaction of tryptophan with acetaldehyde, and the acetaldehyde comes from ethanol. For future work, we're going to continue identifying compounds using both NMR and LC-MS and quantifying those compounds and quantifying how the concentrations change over time. And that's going to help us understand how the sour beer develops its complex flavors. We'd like to thank all of our collaborators. So first, we'd like to thank Brian Doty, who's been really excellent and without whom this work would absolutely not be possible. And we'd also like to thank our undergraduate co-authors, Alexis Cooper, who graduated this spring, and Emily Santa Ana, who is about to start her senior year in just about a week. Finally, we'd like to thank the HeadCo Foundation for the generous gift that allowed us to purchase the LC-MS. And at this stage, we'd be happy to take any questions.
Great. Thank you so much. So if there are any questions from viewers, please state your name and affiliation in the chat window when you ask your question, and I will start with a question. So what led you to study beer, and why sour beer in particular?
Well,
David, why don't you do?
I will start with that. That's a great question. That actually started from a sabbatical project about 6 years ago for me, where I got kind of really interested. You know, you look for research of things that you like. And so we end up liking a lot of sour beer. And so I began a sabbatical project looking at commercial sour beers and their composition. And that led to a poster that was presented at the ACS meeting several years ago on this subject. And that kind of blossomed into a bigger project.
And I got onto this project really, you know, David had been encouraging me for a while. Oh, we could look at this with mass spec and we could see the trace compounds. And I said, well, I'm really busy with some of the other research that I've got. And then Emily Santana talked to me last fall and was really interested in starting up this project. And she was excited about starting a project from scratch. And so her enthusiasm got me really excited. And so together we worked on this project and got enough data that it was really clear we could do a really nice poster with the combination of the NMR and the mass spec data. And now I'm totally engaged. It's just a really, it's a fascinating, complex mixture. And I'm excited to keep making progress on it.
Thank you. So you touched on this a little bit, but the production of sour beer, how is that very different from regular beer?
So for regular beer, the brewers usually choose one strain of yeast to add and work very, very hard to keep other microbes out of the beer. They don't want bacteria, they don't want other yeasts. Because they want a particular flavor profile and they know that the yeast they've chosen will give that flavor profile. Whereas the sour beer brewer is just throwing in all sorts of critters. And some of them, like Brettanomyces, are known to produce particular flavors, but some of them, sometimes the brewers don't quite know what's gone into their beer. If they've let some feral yeast and bacteria fall in, then they don't really know what's there. But that doesn't really matter as long as it makes a good product.
Thank you. Sounds like a lot of just luck sometimes to get a great flavor. So how do the concentrations of the compounds change over time? And how do they differ from batch to batch?
I'll start at least with the NMR stuff, which we've done a lot of kind of several years worth of work on that. And what we see, at least over these 9 batches that Brian provided us, is that of the 4 compounds, ethanol, lactic acid, acetic acid, and succinic acid, they all have delays in starting. So ethanol typically starts immediately because the Saccharomyces yeast has dropped into the fermentation, and that's working away, turning those sugars into ethanol. But even then, sometimes there's a delay of like 2 months before the ethanol really starts to take off. And then we find similar things with the lactic acid and acetic acid, which are coming from different bacteria. Those bacteria need time to multiply and an environment that works for them. And so after about maybe 4 months, then acetic acid begins to grow and lactic acid begins to grow. With all that variability, unsurprisingly, you get to the end of the year that we looked at of all the data points, and you see variability in the final concentration. So some plateau out and they end up about the same. Some end up being much more, some end up being much less. And that is the quandary that the brewer kind of is in, is they can taste that, but they can't really quantify. And so that's the wonderful bit, at least about the NMR work, that we can look at and the HPLC work.
For the trace compounds, there's all sorts of variability. So the hortitines, these things that come from the barley, those levels stay pretty constant over time. And those levels, I haven't gone through to quantify how they vary from batch to batch, but certainly over time, those levels stay constant. The tryptophan, by and large, decreases over time, although there's a couple of outlier batches where it sort of goes up and then it goes down. And so that's an interesting effect. The time lag for the rate at which the tryptophan goes down, there's kind of 2 groups. So there's one group where it goes down pretty quickly and goes down really low. And then there's another group where it goes down and then decreases and then settles out at about 50% of what the initial concentration was. So one of the things we're interested in is talking to Brian about temperatures, and did he put? Is it possible that if he put hops in the beer, that can interact with the bacteria, and so that may change some of their processes. So it's going to be really interesting to correlate the chemical behavior with the other the ways that he brewed the beer.
Thank you. How many different sour beers have you examined?
We looked at 9 batches, and there were usually about 15 samples per batch. And then we also have, and for each batch, it was from a particular barrel. And something that isn't on this poster is that we also have the end result from every barrel that went with each batch. So there's actually more data out there that are waiting to be discovered.
So we have hundreds and hundreds of frozen samples taking up freezer space right now.
So how easy is it to analyze the sour beer with your tools? Because it looked like from the photo that there's a little bit of cloudiness in it. Is that a problem for the analysis?
Well, I'll start with talking about the NMR part. And in fact, what we're trying to do is as little change to the sample as possible to try and preserve its integrity. So basically what we're trying to do is we degas the samples. We want to make sure there's no dissolved CO2 in there. But for the NMR, we simply add the 400 microliters of the beer to an NMR tube, an internal standard, and some deuterated water, and that's it. And so that's all we do for the analysis.
The LCMS, we do have to filter the beer. That you do not want to get large particles into the sample holder or those tiny little lines. And so I do filter the beer. I always run what's called a method blank, where I've just passed water through the exact same filter that I used to filter the beer, and use that as a comparison. And it's pretty clean. The filter doesn't seem to introduce any significant signal. Some of the beer takes a lot of filtering. And I discovered that once the filter is full, you do need to replace it, or it comes popping off of the little holder, and you end up with beer all over yourself, which I discovered with the dark beer samples that we did. And I actually ruined a white t-shirt. So
how could brewers apply your findings?
They can, the hope is that they will be able to understand what are some of the flavor modifiers that can appear, and get a sense of where those might be coming from, and get an idea about the chemistry that's going on. So, there's some stuff that they can control, some stuff that they may not be able to control. If you've got tryptophan and you've got ethanol around, you're going to end up with this particular byproduct that we found. And that's fine. You just need to know that it's there. Other things they can control and potentially understand, so if I add hops, that's going to affect the level of this compound. And so, if I want this compound there, then maybe I need to be more careful about the hops or the temperature, or this particular yeast in this particular barrel are going to end up producing this compound. And if that's something that you want, great, let's keep using them. If it's something that you don't want, that tells you this is not the barrel that we want.
We have a question from Kathy, who's watching online, and she asked, have you considered expanding types of alcohol such as wine, and would this be applicable?
It would be. There's actually, it's interesting. So sour beer and wine have a lot in common because of the aging process. The compounds, some of the compounds that you might find might be somewhat similar. Although again, with wine, usually the winemaker is working very hard to keep bacteria out. Brettanomyces, for example, can spoil wine. But a lot of the process is going to be of actually getting the data and analyzing it would be really similar. So we could certainly turn our methodology that we've worked out to wine. And in fact, it would be really interesting, to be able to track a wine bottle. So I've just opened it up to what is the wine like 2 hours later, because it does sometimes open up and blossom in the glass, to what does it look like the next day, and how does that change? What are some of the compounds that are interesting in there that are changing? And so that's a fun idea. Next time I have wine, I might need to take some samples.
I was curious about the barrels and how that impacts the compounds that you find.
Well, that's a great question. So all barrel-aged beers and wine get stored in barrels, and we think of these as being kind of pristine environments for these wine and beer to age in. But in fact, they're not as pristine as we think they are, because they're full of crevices and nooks, and they get steam cleaned, and sometimes sulfur is used to kill off stuff, but things hide out. And so once you put in this nutrient-rich sauce, those things come out of the wood and then begin to individually affect the flavor profile. Bacteria begin to multiply, they begin to generate compounds. So it's this very interesting interplay. And again, it's something that the brewers don't necessarily understand. And we've talked to brewers before, and they said, we have a barrel, it's just bad. We can't clean it, something's just hiding out, and so we're just going to get rid of it, and we'll work with the other barrels that we have.
Do you have any parting thoughts for the audience?
Enjoy sour beer. It is, if you haven't tried it, I highly recommend it. It tastes very different from regular beer, but it's a very complex and rich flavor experience.
Thank you so much. The archived version of this session will soon be posted at www.acs.org/Fall 2020 press conferences. And this has been our final news briefing from the ACS Fall 2020 Virtual Meeting and Expo. We hope that you've enjoyed these briefings, and thank you for your attendance and participation.